Welcome to Spring LIB.
Hello everyone, today we're doing chapter 11, poem 34. And this poem gives us this reaction, and it lets us know that the conversion of an enol to a ketone can also occur in the presence of a base. And here we have a hydroxide anion as our base. Draw the stepwise mechanism for the following tautomerization. Okay, so if we're given that we know we're starting with the base, oxygen being electron rich, it can act as a very good nucleophile. So what do nucleophiles do? Well, they would take away protons or they will attack electrophiles. So this OH minus, I think the O minus would be happier if it was neutral, right? Because everything in nature tends to go towards neutrality. So if we add an extra hydrogen, for example, we would form water. So let's see what labile protons we have here. So we know that the OH, this alcohol group right here, has a sigma bond between them, and this has a proton that our nucleophile can make a bond with using these two electrons of this lone pair electron. So when we make a bond, you need to break a bond. So now we have those two electrons in that sigma bond going towards oxygen's nucleus. So now if I draw our intermediate, now we have our O minus, that used to be our alcohol, plus water. So now we can go through this tautomerization, and actually let me redraw water to look like this. So if you guys see from the reagents, water is in some sort of equilibrium with OH minus. So, and we know that we're trying to get our tautomer. So using one of these lone pair electrons, oxygen, we can make a new carbonyl bond to make the tautomerization. Making a bond, when you make a bond, you break a bond. So what bond can break? Well, this pi bond can break to give its two electrons form a new sigma bond. It's trying to pick up an electrophile now because this acts as a nucleophile. And it's going to pick up one of those protons from the water, making a bond. When you make a bond, you break a bond. So now what we have is now our keto tautomer with our OH minus. Remember, OH minus in water exists in some sort of equilibrium, so we know that this is a possible mechanistic route.